Thanks to CuriosityStream for sponsoring today's video. Hello maths fans, Dr. Tom Crawford here at the University of Oxford, and today I will be taking the IB Mathematics exam. The IB diploma is taken by high school students in more than 4,000 schools around the world, and it's taken just before they leave school to go to university, which means I'm expecting it to be roughly equivalent to the A-level maths exam that we take here in the UK. However, as usual with these exam-style videos, I have not looked at the exam or the syllabus, so really I don't have a clue. I'll be taking the Mathematics, Applications and Interpretations higher level specimen paper, which you can download for yourself along with the mark scheme at the link in the video description. The total mark is 110. I have 2 hours. I'm allowed a formula booklet and a graphical calculator. Let's do this. Question 1. Whew, okay, blah, 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 blah. There's more instructions, but, you know, who needs to read them at this point? Okay, 6 marks. At the end of the day, the headmaster has conducted a survey asking students about using the internet. Data is shown in the table. Okay, states whether the data is discrete or continuous. So that is definitely discrete data, as we have whole numbers, so you can't have part of a student, so therefore it's not continuous. So that is discrete data. Fabulous. I think that's all I have to do. The mean number of classes in which a student used the internet is 2. So it's telling me the average is 2, and I've got to work out this value k. Right. Okay. My approach is going to be to write down how I would calculate the mean, put that equal to k, and then give me an algebraic equation, I think is what I meant to do. So, part B. Let's do this. Part B. Okay, so find the value of k. So the mean, therefore, which I know is 2. So 2 is equal to the mean. But if I was going to work that out as the expected value, it's 20 times 0, I get nothing from that, plus 24 times 1, so that's 24, plus 30 times 2, that's 60, plus 3 times k, plus 4 times 10, that's 40, plus 5 times 3 is 15, and then plus 1 times 6. Great, and you divide that by the total number of students. So looking there, I've got 20, 44, 74, 84, 87, 88. So 88 plus k total students. So that, I believe, is going to be my algebraic equation. So if we rearrange that, it's going to tell me then, so rearranging that equation, I'm going to get, oh god, 88 times 2, 176. 176 plus 2k has to equal the sum of all of these things. Right, so I know we've still got 3k, and then we've got 84, 124, plus another 21, 145, plus 145. Okay, so let's say that's 176 minus 145 equals 3k minus 2k. Great, so it's just grouping the terms. So that gives me 31 equals k. Right, so I think the answer, and let's just put a box around all my answers. I say that now, I'll probably forget, but for this question, my answers are in boxes. K should be 31, I believe. Okay, now, more information. It was not possible to ask every person, so the headmaster arranged the student names in alphabetical order and then asked every 10th person. So I don't know how many there are though, do I? No, but okay. So there's some organization to how it's being done. Of course, I knew this question was coming before I even looked. Identify the sampling technique. Oh, God. So, I'm just laughing. I teach both first year and second year undergraduate statistics here at Oxford. And obviously we don't talk anything about sampling techniques. So I'm just laughing that I can tell you all about hypothesis testing and Bayesian statistics, but I can't tell you sampling techniques because I don't remember. So it's definitely not random. I know that much. It's definitely not a random sample. It's not a complete sample because he's not sampling everybody. So it's sampling, I can't even, would you say it's proportional or representative? So it's not representative actually, because he's just putting them in a list and then sampling at a certain point on that list. Oh God. I'm not actually sure what the specific name of sampling I'm supposed to know is. Like organize. I'm going to go with organized sampling because it's definitely not proportional, which I know is the thing. It's not like a proportional representation, and it's clearly not random. So it's some kind of, I don't know, organized question mark. There's absolutely no way that is correct, but I'm attempting, to all of you at least, to explain that I know which ones it isn't. I just don't know the word that I meant to write down. Anyway, right, that's question 1. So let's go on to question 2. Okay, perimeters. The perimeter of a given square represented by the function p of, okay, so the perimeter of A is equal to 4 times the square root of A. Great. Where A is positive, it's an area, yes. We have a graph of the function for A between 0 and 25. Yes, we do. Okay, write down the value of P25. Okay. So I can either read the graph, which is going to give me 20, or I could actually just calculate it. Square root of 25 is 5, 4 times 5, 20. So however I do it, I can say P25 is indeed equal to 20. All right, and I actually remembered to put a box around it. Apparently, someone's trying to mine for something in the room next to my studio. So maybe they found it. Okay, part B. On the axes above, draw the graph of the... I'm just going to wait for the mining to stop. All right, part B. On the axes above, well, I'll draw my own graph. Ooh, they're probably going to mark me down for not drawing on the correct axes, but I am currently writing on my iPad on a blank page, so you're going to have to deal with it, marker. I will draw the graph as accurately as possible, like so. Okay, it's something like that. I'm pretty pleased with my graph, and I'm going to make sure I'm not feathering by shading it in, because we all know that you can't feather. Apparently, you lose marks for feathering. So that right there is a non-feathered graph. I've just gone over it several times to make it bold. All right, I didn't even read what the question was. Draw the graph of the inverse function. Okay, interesting. Oh, interesting. So it's going to be reflected, isn't it? Yes. So I need to reflect this graph in the line y equals x. That's how you find the inverse. So I'm going to write that to emphasize that I know what I'm doing. X and y are like swapping roles when you do that inverse. So this is A and this is P. Or in this, I'll put in square brackets, P equals A would be the appropriate line here for these variables. So if I draw that in a dotted line, now where are they equal to one another? 10, 12, 14, 14, no, not quite. Somewhere between 12 and 14, no, 14, no, 12 and 14, and then you go to 14, and that one's like pushing up. Is it 16? They're equal at 16. Yes. Yes, they're equal at 16, right. So it's got to go through that point, great. So they are equal to one another at the point 16. So that's going to be like here. Let's call it here, right? So I'm going to call this on my very not to scale or accurate graph. This is 16. And then that means that this up here is also 16. Because, yes, when the area is 16, the perimeter is also 16. Right. Now, if I change color, and now we want to do is reflect in this y equals x line. So let's draw that in dotted, which is going to go through this point and up here. Okay, so this is the y equals x, or here p equals a line, and you want to flip in that line. So again, different color, sort of dark bluey grey color. It's going to curve low down here and then come up and do that. Again, not feathering, just going over this to emphasize its shape, definitely not feathering. It's going to look something like this. So this one right here is P inverse, and the original one in black there is P. Obviously made that hard for myself by not using the actual axes, but pretty confident that's what they were looking for. All right, in the context of the question, part C, the context of the question, explain the meaning of P inverse of 8 is equal to 4. Right, so this is the perimeter, and then so going forwards, P of A is saying input an area and we'll give you the perimeter. So then P inverse is starting with the perimeter, so you input the perimeter, you get back the area. So it's saying perimeter 8, when perimeter is 8, area is 4. That's what that is telling you. It's going backwards. Given a perimeter, it's telling you what the area should be. Okay, right. I think, yes, end of question 3. End of question 2. Getting ahead of myself. Now, we're on to question 3. Professor Vinculum, eh? Anyone? Okay, I think I remember what a vinculum is, but throw out to the audience watching this. Write in the comments if you know what a vinculum is without looking it up. I'll be intrigued as to how many other people might know this. I only know it because it came up in a weird game show quiz I did a couple of years ago. But I'll be interested to know if any of you also know what a vinculum is. It's a maths thing. So Professor Vinculum, classic. Investigated the migration season of the bulbul bird. This is so many things going on here. From their natural wetlands to a warmer climate. He found that during the migration season, their population can be modeled by, we have an equation. Right, so let's start writing this down. Helpful things. Question 3. We have an equation for the population. So P is equal to 1350 plus 400, and that's multiplied by 1.25 to the minus t for positive time. Great. So it's going to start at 1350, and then as t gets bigger, that's going to increase. So it's when t is 0. Okay, so I'm going to make notes to myself. So that starts at 1750 at t equals 0. So that's the population in the wetlands, yes. Okay, and then it's going to decrease as they migrate away, and so it ends, yes, and so it ends at, it's going to be decreasing, but it's going to be an asymptote. So it ends at 1350, which is as t tends to infinity. All right, let's look at the actual question. Find the population at the start of the migration. It's almost like I know where these questions are going. Okay, part 1. The start of the migration season. So start is equivalent to t equals 0. So P is 1750. Because when t is 0, you get 1 for that. So you add on the 400. Perfect. In the wetlands after 5 days. So we now want when t is equal to 5, because 5 is days. Yes, good. Calculator. To calculate for this. Okay, so that should be P is 1350 plus 400 divided by 1.25 to the power of 5. It's on the bottom because we had a minus t, telling you it's on the denominator. So I'm going to put this in my calculator, which is on my laptop, so I don't have a working calculator, as those of you who've seen the, oh god, was it GCSE or A-level? Some of my earlier ones, I don't have a working calculator, but the internet does. Okay, 1481.07. So I'm going to say that's approximately 1481. Okay, put it in a box. Put it in a box. May have forgot to do that on the last one. Yeah. Okay, just help me when I come to mark this later. Part B. Yes. What to do now? Calculate the time taken for the population to decrease below 1400. So T is unknown, and I want P less than 1400. Right, so if I sub that in and make an inequality and try and rearrange for T. So I need 1400, and I want the population to be less than, so that has to be greater than 1350 plus 400 divided by 1.25 to the T. Okay, so that means I need 50 needs to be bigger than 400 divided by 1.25 to the T, which means I need 50 multiplied by 1.25 to the T to be greater than 400, which means 1.25 to the T is greater than 400, greater than 8. So when does 1.25 to some power become bigger than 8? So I could probably just solve this in my calculator, but I reckon I can guess. So that's probably a terrible idea, isn't it? Fine, I'll solve it. Okay, fine. So if I actually had to solve it, just to be safe, because if it has to be a whole number, then it's 10 days, but I'm imagining 9 point something, probably what it wants. So if going back to this point, what can I say now? I can therefore say, I need to take logs of both sides, so that means T times natural log of 1.25 needs to be greater than 8. So T needs to be greater than 8 divided by natural log, not 8, log of 8. Let's write that one again. We need T log 1.25, taking logs of both sides, needs to be greater than log of 8. Both of those are positive. Both of those are positive, so that's okay. So we need T to be bigger than natural log of 8 divided by natural log of 1.25. Right, calculator, 9.32, thank you. Okay, serves me right for not getting it right, okay. Anyway, so I think T is approximately 9.32 days, and I'm spent too long on this, so I'm gonna go with that. Is that it? Please tell me that was it for the birds and vinculum and his thing. Oh, no, there's a part C. Okay, great. Let's go to the next page. According to this model, find the smallest possible population of the birds during the migration season. Let T go to infinity. So that's just let T go to infinity. P will tend to 1,350, which is an asymptote. So that right there, it never quite gets to 1,350. So it's 1,350 or 1,351. But I assume it will give you marks for both. Otherwise, that's me. I'll write 1,350. All right, now it is the end of Professor Vinculum and his birds. Okay, number 4. What are we doing over here then? Whew. Okay, it's very warm today. Probably should have mentioned this at the beginning in case you see me dripping with sweat. Could be from the intensity of this exam, but it's also exceptionally warm at the moment in the UK. All right, various points are representing snow shelters in the Blackburn National... I wonder where Blackburn National Forest is. So I grew up in a place in the northwest of England called Warrington, and Blackburn is a town in the northwest of England. However, I have not heard of a Blackburn National Forest. So I don't know if this is referring to the forest 20 miles away from where I grew up. Probably not. But in my head, I'm picturing that. Snow shelters, okay, it's definitely not. We don't really get snow in England. Snow shelters in the forest. They're illustrated using the following coordinate axes, blah, 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 diagram. Okay, calculate the gradient of the line segment AE. Let's try that. So, where are you, A? A is at 3, 1. Okay, so point A is at 3 across and 1 up. Assuming that they're going to be whole numbers, I think they will be. and E is 7, 3. Okay, and E is 7, 3. Right, and what do I want? The gradient, the segment between them. So gradient is delta y. Rise over run is the classic, but I just remember it as delta y over delta x because it's like dy by dx, which of course derivative gives you the gradient. Good to see the mining's back. Okay, so change in y, 3 minus 1. So 3 minus 1 is going to be 2 over 7 minus 3, which is going to give me, is that right? Yes, it's positive, I agree with that. 7 minus 3 is 4, so it's going to be 2 over 4, so I think it's a half. I think it's a half, all right. So the gradient, which is equal to a half. That's it, and it's positive, yep. All right. Question continues on the following page. Oh dear. The park ranger, classic park ranger spoiling my fun, draws 3 straight lines to form an incomplete Voronoi diagram. I'm sighing. I've heard of these. I never studied them at school. I've come across them since, very briefly, in sort of, I don't know, random puzzles or things, or seeing like interesting applications of them, because they're actually really cool things, as I thought, this is what the question's getting at. But I've never actually formally studied them. So this could be fun. Of course, find the equation of the line which would complete the cell containing E. All right, now, I do know that a Voronoi diagram creates a polygon around each point, which is, if you were to draw a straight line between 2 points, it's the midpoint, which forms the side until it like intersects another midpoint, and then that gives you your mash of polygons. I believe, at least, based on Euclidean distance, standard way, measuring distance. So if I'm going with that as my interpretation, we've got a line between E and C, we've got a line between E and B, and we've got a line between E and D. So only E and A, and I just worked out the gradient. Okay, now it makes more sense, because I've done part of the work. Okay, so what I need for part B is, I need the midpoint between A and E, and then I need the line through them with the opposite, wait, I'm saying that wrong. If I were to join up A and E, I know that gradient is a half, and I want to be at 90-degree bisector of that line. So I want to be -2. So the gradient, yes, and the gradient is -2. Okay. So I need a line with gradient -2 that passes through the midpoint. Now, what's the midpoint? Between A and E. Oh, I don't actually know. Okay, let's kind of draw a little bit of a diagram. It doesn't help not having a diagram. So if this was A and E, so this is E, this is A, right. So A is at 3, 1, so I'm going across 4, and I'm going up 2. Okay. So the distance between them, marvelous, is what? Pythagoras. So let's try that. So I know that, let's call it h. So I know that h squared is equal to 20. So h is, oh no, really? 2√5? Not sure about this. I'm probably overcomplicating this. I'm massively honestly. So could I not go 2 across and 1 up? Similar triangles. If I go 2 across and 1 up, then that's exactly the same as going another 2, another 1. Yeah, perfect. So that's 2 of them. So this is the midpoint. Woo! I mean, I probably could have used the √5 and figured out the size of the other triangle which is root 5. Now I've just seen it. Anyway, okay, so that location. So midpoint is at, so I'm going 2 across from A. So where's A? 3, so it's at 5. I'm going 1 up, so it's at 5, 2, because I go another 2, another 1, and I'm at E. Right, we've got there. Gradient's -2, and it's got to go through the point 5, 2. So I know that y minus y1 equals m the gradient times x minus x1. So that here tells me y minus 2 has to equal the gradient, which is -2 times x minus 5. What did I want the answer? Ax plus by plus d is 0, so that's going to be y minus 2 equals -2x plus 10. So y plus 2x minus 12 equals 0, I believe, is your answer. All right, and in the last bit, the context. Oh, he did tell me they were integers. I just realised the end of, it may be a little bit. Anyway, I have integers, I'm happy. The context of the question, explain the significance of the cell containing site E. Right, so this is pretty much my only understanding of Voronoi diagrams, is the cell is all points within the cell, are closer to E than any other point, are closer to E than any other point. I think. Again, if I've remembered how Voronoi diagrams work. All right, let's move on to number 5 and a very fun looking diagram. Okay, question 5. What are we doing here? Helen, well, what am I doing? Helen is building a cabin using cylindrical logs. I've learned 2.4, right. So if I had the full, draw it, it's drawing it the wrong way around, this is why I want to draw it, but anyway. So let's draw the full, it's not straight, let's draw the full cylinder over here, right. 2.4 meters, and we know what 8.4 centimeters is the radius. Okay, so that's 240. Pull my units in the same at the beginning, so I don't get confused later. Okay, wedge is cut, yes. Find 50 degrees in radians. Right, so that's part A. 1 rad is, pi radians. Pi radians is 180 degrees. That's what I know. Yeah, pi is 180. So 50 degrees, therefore, so 50 times pi over 180 is what I want. Right, calculator. 0.873. So 3 significant figures that I weirdly remembered from the instructions. 0.873. And I already knew this was coming. Find the volume of the log. So it's making me convert to radians to help, to be fair, to help with the volume calculation. So as soon as I saw this diagram, I knew this was the question. Find the volume of this weird shape. Right. Okay. If only I was a woodcutter, eh? Lumberjack. That's the right one. Lumberjack. I do have a lot of lumberjack shirts. Okay, so what's the total? Right, so the total, if it were a whole cylinder, is going to be pi times the radius squared. So pi times 8.4 squared times the length, which is 240. And then we've chopped off a wedge of that. We've chopped off exactly 50 out of 360 of that. Yes, so we removed 50 out of 360, like 5/36 of it has been chopped and it's all equally done. So therefore the remaining percent, so 31 out of 36 fraction remains. So therefore the volume is just that. This almost feels too easy. Volume is just 31 out of 36 times the whole thing, I think. Times pi times 8.4 squared times 240. Right, well, let's put that in the calculator and see what we get, eh? All right, 45812 approximately. 812 centimeters cubed. Does that feel right? Yes. Go on then. It almost, it's like, was that 4 marks? For 4 marks, it almost feels too easy, but maybe it's that understanding of proportion. And anyway, I probably already spent too long, so we'll go with it, and I'm going to put a box around that one for part A. Yeah, cool. All right, 5's done. Okay, number 6. Moving on. Jay He plays a game involving a biased 6-sided die. Ooh, the faces are labelled with different numbers. Okay, and it's biased, right. The score for the game is the number which lands face up. Great. So the distribution of what you can score. Okay, and again, missing value. So the total probability has to be 1. I believe, yes. So that's going to be P, right. So total probability equals 1. So therefore 1 over 18 plus unknown value P plus 3/18 plus 1/18 plus 2/18 plus 7/18 must be 1. How many have we got? We got 1, 4, 5, 6, 7, 14. So P plus 14 out of 18 equals 1. So P is 4 out of 18, which of course is 2/9. Great. That can go in the box. Okay. Jay He plays the game once. Calculate the expected value. Great. Love it. Very similar. Feels very similar to question 1. So you multiply the probability by its value, add them together. So it's minus 3/18. So let's write it here. E of x is minus 3/18 minus 1 times P, so minus 4/18 plus 0 times whatever, plus 1/18 for 1, plus 4/18 for 2, and plus 5 times 7 plus 35/18 for the last one. So we're going to get minus 3 minus 4 minus 7 plus 1 plus 4 minus 2, 33 out of 18. I believe is the expected value. I like this question. Plays the game twice, part C, and adds the scores together. Sure. Find the probability he has a total. Okay, so total from 2 games equals minus 3. Right, so we have to work out how could he get minus 3 in those 2 rolls, and then the probabilities of those potential outcomes. So if he's going to get minus 3, okay, so if he gets, he can get a minus 3 and then a 0, or he could get a 0 and a minus 3. Then he's got minus 1, 2 of them, that wouldn't be enough in 2 games, and all the others are positive, so they are useless. All right, so they're the only 2 games he can get. That would be 1/18. These are independent, so it's 1/18 times for the minus 3, and then the probability of getting a 0 is 3/18. And it's going to be the same, but the other way around for the second one. So it's 2 lots of that, which is what? 18 squared. I don't want to do this in my final, do it in my head. 360 minus 36 is 324. Sounds about right. Okay, let's go 324. So it's 6 out of 324. Meh. All right. Is that it? The probability of total square minus 3. That is it. End of question 6. Alrighty. So number 7, new page. Ooh, a particle A moves with a velocity. All right, so V is equal to 2 sine of t. Feels like a physics question coming. The kinetic energy of the particle is measured in joules, and E is equal to 5v squared. All right. Right, an expression for E is a function of time. So E there is just 5 times 4 sine squared of t, so it's 20 sine squared of t. Great. And the energy is always positive, that's what we like. Find dE by dt. Right, differentiate. So if that is E, if I now calculate dE by dt, so I'm going to bring down the 2 and get 40 times sine of t, and then the chain rule says I have to differentiate sine. Oh god, I always get these wrong. So if I differentiate sine, I get cos with a plus, so that's fine. Okay, happy with that. Part C, racing through these now. Hence or otherwise, find the first time at which the kinetic energy is changing at a rate of 5. So I want to solve for time when the change in the energy, which of course is dE by dt, is equal to 5. So I want 40 sine of t cosine of t to equal 5. Okay, so that's sine of t cosine. I'm going to keep a 2 there. I'll explain why in a second. Is equal to 5 divided by 20, which is a quarter. Right, so I've got 2 sine t cosine t is a quarter, but that is sine of 2t. Double angle formula, so it's the same as sine of 2t is a quarter. Okay, so that means sine graph, what does that look like? That one, when is it? A half? It's not a half. No, it is a half, isn't it? Oh, think about this, think about this, think about this. I think you get a half. Yes, you do. When first time, okay. So I was just about to say this obviously oscillates, so it will reach that energy several times, or that change of energy several times. But we want the first one, and t is positive. So on the first time it hits a quarter. Okay, so 2t is a quarter. Right, so what I want then is when this is like a quarter. Okay, so let's solve. 2t then is sine inverse of a quarter. So let's calculate that. 0.253 radians. So 2t is 0.253 radians. So if 2t is 0.253 radians, then t is half of that. So that's going to be 0.126 or 127? 126. Let's see what the calculator say. Yes, to 3 decimal places. 0.126, I think, is the time. It's quite quick, quite quick. And is that it? That is it. All right, question 8. What do you have for me? A fun-looking diagram. Okay, question 8. Ollie has installed security lights, very security conscious of you, Ollie, on the side of his house. They're activated by a sensor. Oh, it's like real-world trigonometry. The sensor is located at point C, directly above point D. Okay, there's a whole diagram, blah, blah, blah. Right, so it's explaining the diagram. Cool. Find CAB. So that's CAB, right. So I'm just going to draw the triangle to help myself out. So we've got funky thing, flat, funky thing. Okay, so I can't use trigonometry actually because I don't have any right angles at the moment. And you know this is 4.5. This is A, B, C. I know this one is 15 degrees. Great. And I know this is 6. Okay. Right, and I want CAB, so let's put that in a different color. Just to emphasize CA, I want this one. And let's call that my unknown X. So, how would I solve for x? Well, I know from the sine rule that sine of x divided by 6 is equal to sine of 15 degrees divided by 4.5. Yes, so therefore sine of x is 6 divided by 4.5, that's 4/3, right? Yes. Yep. 4/3 of sine of 15 degrees, which is, calculator, 20.182 degrees. X equals 20.182 degrees. All right, does that sound right? Yeah, because the other one's quite big. Yep, I'll buy that. Okay, what do next? Okay. Point B on the ground is 5 meters. Ooh, okay. I need to improve my diagram. It's 5 meters from point E. So there's like a little bit here. This comes down. This sort of continues, right? And then there's another bit here. Right, so this bit is 5. That's D, right? Yep. Okay, and he's 1.8 meters tall and he's standing at D. So somewhere up here is 1.8 meters. Yes. He walks towards point B. This is quite neat. Find the distance Ollie is from the entrance when he first activates the sensor. So, if I have understood this question, which is a big if, he stood far away so that he's below the height of the sensor. And then he's going to walk, and as he does, his head is going to be the first bit that cuts into the beam. And so we want to know when this bit moving across, so we want to know if we move this bit across here, when does that become, this line, become 1.8? And then if we know that, oh God, we then can work out, so the total's 5 and we want to know what the short one is, and then we want the bit that's left. Right. So let's work out the triangle. So what do I know? Oh, do we know an angle? We do know angles from 180 degrees. Right, okay. So let's start adding some things in. So if x is 20, let's call it 20.2. And then we've got 15. So 20.2, so this is B. 20.2 plus 15 is 35. This is like a real, this feels like a real question. I like this. Got to figure a lot of stuff out. 35.2, then 180 minus 35.2 is the other angle, is Y. But then B is 35.2, right. See, this one is 35.2. So I now have a right angle. Oh, this is beautiful. Right, so I have a right angle. Let's change back to black. I have a right angle triangle, which looks like this. We know this one is 35.2 down here. We know the height is 1.8, and we know that is a right angle. So that right there, and I want to know, let's call this unknown value Z. So I can say that tan of 35.2 degrees is equal to the opposite over the adjacent 1.8 over Z. So Z, the amount I want to know, is 1.8 divided by tan 35.2 degrees. So let's work that one out. So Z is 2.55, and I want to know the total distance from the house, which is 5 minus that. So therefore the answer, so 5 minus 2.55 equals 2.45. Squeeze it down in the corner. That right there, ladies and gents, is your answer. 2.45 meters. Great question. I hope 9's as exciting. That was felt like a real world math problem I was solving there. That was cool. All right, number 9. What are we doing now? A manager wishes to check the mean weight of flour put into bags in his factory. He randomly samples 10 bags. Okay, so n is 10. It's a statistics question, can already tell. N is 10 is going to be helpful. The mean, so x bar, that's going to be your sample mean then. From that is 1.478. Yes, and the standard deviation of the sample. Okay, so I was just looking at the notation. So I think what they want to say here is SN, so the standard deviation of the whole sample, is 0.0196. Sure. Find Sn minus 1. Okay. So I've labeled the sample mean with x bar because he has randomly sampled 10 bags and he's found the mean of that. So that is the sample mean, which you would normally label x bar in a statistical setting. And then it says the standard deviation of the sample. So I don't know whether that's the actual standard deviation or whether that is the sample standard deviation, which is where you use n minus 1 in the formula for the variance. So the fact that it labels it Sn and is now asking me to calculate Sn minus 1, I think is referring to exactly the sort of notation I'm confused by. So this sounds to me like maybe it's formula booklet time in terms of how they relate. So let's have a look. Where are you? I did get this from somewhere. There we go. Right, formula booklet. Statistics. Probably lots of other formulas I could have used in here, but anyway. Okay. Unbiased estimate of the population variance. Right. So we're told that Sn minus 1, therefore, is the square root of n over n minus 1 times Sm. Fine. So if I go back, anything else? No. Okay, so if I go back to the question, so I know all of those things. All right, so that's just simply the square root of 10/9 times Sn, which is 0.0196. So it's slightly bigger because it's more uncertain. All right, there's more uncertainty, I'll believe that. So again, calculator 0.0207. 0.0207 to 3 significant figures. Sure. Is that the answer? Meh. I think that's the answer. Right, so B. Find a 95% confidence interval for the population mean, giving you an answer to 4 significant figures. So maybe I need the 6 up there. Okay, so let's just throw that one at a 6. All right. How would I calculate a 95%? So I know that a 95% confidence interval CI would be x bar plus or minus 1.96. Now I would write sigma, so let me just write sigma, and then you divide by the square root of n. That is a 95% confidence interval from what I would teach my students. Now, but that's if we know sigma. Wow. But we don't know sigma. So do we just replace sigma by Sn minus 1? That's the question. I'm not entirely sure what they want me to do. So if I replace, let's see, so if I estimate sigma by, yeah, do I believe that? I think I believe that. If we estimate the actual unknown standard deviation by SN, it says for the population mean. Ooh. All right, I think SN minus 1, because they've asked me to calculate that. So that would imply x bar, which is 1.478 plus or minus 1.96. So the 1.96 there comes from the standard normal, which is what you're doing here. You're basically using the central limit theorem to argue that it's all normally distributed, blah, 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 I think is what they're trying to get at. So it's 1.96 for the 95% multiplied by Sn minus 1. Right. But do you use root n or root n minus 1? I'm not sure. All right. So I'm going to use Sn minus 1, which is 0.02066. I'm going to divide by the square root of 10. It's going to be close. I don't know if it's necessarily what they want, but let's try it, hey? I feel like I'm doing something sensible. In my head, I'm doing something sensible. But I feel like there are some things here possibly that are very specific to how this course is taught compared to perhaps how I would now teach my undergraduate statistics courses. Anyway, I'm just making up excuses because I am really not sure what exactly I'm meant to do, but I can work this one out. It gives me 1.491. Okay. So I think my 95% CI is given by, apparently someone's mining for it, it's given by 1.491, right? And the lower one, so the same thing with a minus 1.465. Okay. I mean, probably correct. I've just realized I could have just subtracted off the same bit that was above x bar, but anyway. Sure, I don't know. I don't want to dwell on these too long. This is supposed to be a speed run in inverted commas. Okay. Find 95% confidence interval. Right, let's go with that. C. The bags are labeled as being 1.5 kgs. Comment on this claim with reference to testing. Do you understand confidence intervals? Because they are tricky. Okay, comment on this claim with reference to your answer in part B. So the endpoints of the confidence interval are both less than 1.5. So this would seem to suggest that, so by part B, 95% of samples of size 10 would contain less than. Because 95% of such samples would have a mean in this range, given by the CI. The CI is less than 1.5. The whole CI is both endpoints below 1.5. So 90% of samples of size 10 would contain less than 1.5 kg. So seems likely, weight is less than that. So in other words, it's like doing a quality assurance test in a way. They're advertising it as 1.5, but in the 95% confidence interval, both endpoints are less than that 1.5. So that's saying like the vast majority of this stuff is going to be less than that. So they're kind of false advertising to a degree, depending on how accurate you're supposed to be. Okay, so I think likely the mean weight is less than the 1.5 that they're advertising. Okay, let's do number 10. Oh, a couple of long, intense questions there. You can see the difficulty is ramping up. In the coffee shop, the time it takes to serve a customer can be modeled by a normal distribution with a mean of 1.5. Right, let's write this down. So let's say x is normal of mean 1.5. Another stats question. A lot of stats. Standard deviation 0.4. So normally you write that as sigma squared. Right, so I'm being told that this is mu, and I'm being told that sigma squared. So sigma, standard deviation, 0.4. Okay, 2 customers enter, they are served one at a time. Find the probability. Ooh. Okay, so there's 2 of them. They're served one after the other. Total time, so I want to know what's the probability that x plus y is less than 4. Okay, where x and y, clearly state any assumptions. Okay, so I am saying that x and y are both normal 1.5 and 0.16 when I square that out. They are independent events because that allows me to assume that one doesn't influence the other. And if you have 2 normals which are independent and you add them, you add their means and you add their variances. So the mean is linear, the variance is sort of linear, you just have to square the coefficient. Is how I think of it in my head, but you can definitely just add them. So that means that x plus y belongs to normal of 3, 0.32. So we're being asked, so let's call that z. So we want to know what's the probability that z is less than 4 when z is this normal distribution. That's something my calculator would do, isn't it? It tells me that's 0.961. 0.961. And then there'd be a 4, but that's the 3 significant figures. Great. So they are almost certainly going to be served in less than 4 minutes. Okay, number 11. Vectors. Okay, question 11. Something going on here about vectors. Particle P moves with a velocity v. Right, so v is minus 15 to 4. And B, my magnetic field, is 0 d1. Sure. Given that V and B are perpendicular, find the value. Right, so we know that V dot B is 0, which means minus 15 times 0, which means 2d plus 4 has to be 0. So 2d is minus 4, so d is minus 2. All right, love it. That was part A. And now part B. The force produced by P in the magnetic field is given by the vector. Ooh, when I saw this, I was thinking cross products. Got Maxwell's equations tattooed up here relating electromagnetic fields. Straight away I thought of it when I saw this question. Okay, so F is A, which is an unknown constant that they want me to find, of course, times V cross product with the magnetic field B. Great. So what do we know? Okay, let's work that out. So let's do the cross product then. So A times V is, so you've got I, J, K. Whether they're supposed to do this by hand or on the graphical calculator, I don't know, but I am going to do it by hand by calculating the 3×3 determinant to get the vector product. So it's ijk, and you've got A times V. So minus 15A, 2A, and 4A. And then we've got 0D, which we know is minus 2 now, and 1. Right, so let's calculate that determinant. And I'm going to use a different color just to help make sure I get this correct. So we're going to cross off these 2, which leaves me with 2A minus 8A, so 10A. All right, let's write that one there. 10A. Then we cross off the middle one, which then leaves me with minus 15a, I think. No, but it becomes a plus because of the change in sign. Yep. And then finally we cross off the last one, and it's minus 15a times minus 2, which is 30a, and then we minus 0. Right, so that's f. Now, what are we told in the question? That's a question, isn't it? Mod f, okay, so if mod f is 14, so if I square that, it's 196, and now let's calculate it. So that has to be, pulling out the a, that gives me an a squared times 100 plus 900 from the 30 plus 15 squared, 225. So a squared is 196 divided by 1225. So a is the square root of that, which means calculator time. Oh, 0.4. Cool. All right, a is 0.4, I think. We're going with it. I think I'm supposed to be getting a move on here. Right, come on. Number 12, let's keep this rolling. Product research leads a company to believe that the revenue made by selling its goods, blah, blah, blah. Nice economic equation. There are two competing models. Okay. The company experiments by selling the goods at different prices. Sure. The company will choose the model with the smallest value for the sum of square residuals. Okay. Determine which model the company chose. Okay. Fun. More stats. I feel like I've done way too much stats here, but anyway. Let's go to question 12. A lot going on. So, as always, when there's a lot going on, start by writing down formulas. Okay, so model A has C is 3, and D is 0 minus 0.5. So it reckons that for a certain price, it should output 3 times the price times e to the minus 0.5p. Okay, now compare the model to the revenue, and then we want the sum of the square residuals. Oh, so you want to think about this now. Calculate what the model is predicting, compare it to the real value, subtract them, square them, add them together. I'd call it a regression model, but I mean, maybe it's referred to as a regression model when this is taught. But that's why we look at the sum of squares. It's actually a maximum likelihood estimator. Tells you to minimize the sum of squares, which you'll learn at university. Very interesting stuff. Okay. So price, so when p is, okay, so I need to plug in when p is 1, when p is 2, and when p is 3. Oh, fun. More calculator stuff. Okay. And then the actual values that they got, 1.5, 1.8. Okay, so this is like actual here. 1.5, 1.8, 1.5. So we want the difference of them, square it, and add it up. Okay, so sum of squares then is 1.82, so that's just 0.32 squared. Great. Plus the next one is going to be 0.407 squared. And then finally plus 0.508 squared is 0.526. I believe is the sum of squares for model A. Let's do the same now for model B. Right, same idea. So model B is going to give me slightly different values because now, what are we using? C is 2.5. And D is now minus 0.6. Right. So when P equals 1, P equals 2, and P equals 3. We do. Okay. 2.5. Let's write what the formula is. So R of P is 2.5P times e to the minus 0.6p. Right, so same idea. Actual minus this, so the sum of the squares, let's call it residual sum of squares, is 1.372 and 1.5, 0.118 squared. 1.506 and 1.8 is almost 0.3, so that's plus 0.294 squared. Yeah, and then third one, 1.24 and 1.5 is 0.26 squared. Can already tell it's going to be smaller, but I'll put it in the calculator nonetheless. Okay, so much lower. Yeah, so choose, let's write it up here. Choose model B, because it has the smaller sum of two squares. Didn't like that one. A lot of calculation. Didn't like it. All right, question 13. Ooh, coupled ODEs, I say. The rate of change of area covered by two types of fungi given by the following equations. Right, so this is very advanced. So this, I would cover this in second year differential equations and mathematical biology courses here at Oxford. So it's very cool that this is being covered at school. Very nice. Well played, IB. I like this. And a fun question. Definitely a fun question. Various things, eigenvalues, blah, 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 sketch trajectories, phase planes, right. This is what I like. So, part A, although maybe I know too much and go into too much detail, we'll see. It's giving me a load of information. It's asking me to find dy by dx. So I know that dx by dt has an equation, which is 3x minus 2y. And I know that dy by dt has an equation, which is 2x minus 2y. So therefore, dy by dx is, let's call this x dot, and y dot is just y dot over x dot. So that's just 2x minus 2y divided by 3x minus 2y. And I want to know that when t is 0, and I'm given the initial values, right? So I'm told initially x is 8 and y is 10. Cool. So I can say that this at t equals 0 is 16 minus 20 minus 4 divided by 24 minus 24, so it is minus 1. Okay, now sketch, right. There's a lot of stuff that I might need to do here. Okay, I'm going to write everything down and then I'll draw the sketch. So, what do we know? We now know when lambda is 2, we know the eigenvector has direction 2, 1, and this is the stable branch. So this means for the fixed point, things come towards it along this direction. And then, no, unstable, because it's positive. Sorry, positive eigenvalue means unstable because it will grow exponentially. Now, lambda minus 1, we have 1, 2 as the eigenvector. That one is the stable one. And I'm going to guess the fixed point. Yes, so fixed point is when x dot equals 0 equals y dot, which is equivalent to 3x has to be 2y and 2y has to be 2x, so x and y are both 0. Great. So we have a fixed point at 0, 0, which is where the trajectories, in theory, are happy and want to settle. But we've got these two branches, which means it's a saddle point. So there's one direction where things will go towards the fixed point, which is the negative eigenvalue along the corresponding eigenvector. They'll come in along that, and they'll go out along the other one. So it's going to depend which one we start near and what directions things are pushing as to where we move. Okay, so I know where we start. We start at 8 to 10 up here. We've got the directions, so I just need to know where things are pushing. So that's determined by the null lines. So the null lines are when your equations are 0. So when x dot is 0, means x doesn't change as you cross that line, and so you have to cross it vertically. And when y dot is 0, y doesn't change when you cross it, so you have to cross it horizontally. And they're really helpful because the direction switches as you cross them. So we know that x dot, so horizontal, when y dot is 0, because that tells me that y isn't changing, yes, and that is when y equals x. And we know it's vertical when x dot is 0, so there's no change in x, and that's when y equals 3 over 2x. Okay, good. And then think about the signs. So when x is, so if x is small and y big, y large, then what can we say? X dot is negative. Great. And when, what do I do? Let's do x is large and y is small. When x is large and y is small, y dot is positive. Yes. Whew. Okay, I think I have enough information, so let's try and draw. I think I'm overthinking this. I want to say we're going to kind of move towards 0, 0 along the stable branch. Now, but why aren't we going up there? Because y dot, what's bigger here? Y is bigger than x, so y dot is taking us down. But then if that one sends us down, that one sends us that way. All right, I think we are in some way heading negative. All right, I think we move towards 0, 0 on along the stable branch. I think I have massively overthought this question. So I'm going to put move towards 0, 0 along stable branch. So i.e. in that direction. So what was that direction? That was the 1, 2 direction. So yes, i.e. 1, 2 direction. Okay. Right, I really need to move on. So, okay. The pitfalls there of knowing too much and getting way too involved in the question. All right, anyway. Number 14. As pretty as your picture is. Question 14. What are we doing now? Okay. Whew. The graph of a function is given. Marvelous. Y equals minus x cubed is transformed onto the graph. Okay, so y is minus x cubed is moved to y equals 33 minus 0.08 x cubed. Right. By a translation of a units vertically, so we've translated 33 upwards from where we started, yes. Oh, this is what it asked me to do. And stretch parallel to the x-axis. Okay. Oh. Now, so we've gone from x to bx, which means we went from x cubed to b cubed x cubed. Right. So how have we stretched that? So am I saying, this is now the question, and this is where I get a little confused on these. So I don't know if b cubed is 0.08 or if it's 1 over that. Either way, let's work out the cube root of 0.08. Okay, is 0.43. Okay. So, have we shifted by that or have we not? So if I look at this graph, okay, so a graphical calculator would help. So if I have x cubed, and then we've made it y is minus, so it was x cubed, it was minus x cubed, and now it's wider or shallower. I can't tell if it's 0.43 or 1 over b is 0.43. So that would mean b is, what's that then? 1 divided by 0.43, 2.32. It's one of those two, and I always forget which one it is. I can't remember whether you have to invert it. I'm going to write both down. We'll see. I don't know. We'll see how I get to when I mark it. I'm getting quite tired and warm. So it's one of those two. I'm leaving it at that. So put that one in a box. And I'm going to say it's both of these two. Because I can't remember. Okay. So I want to do the interesting question, which is the some kind of, yes, volume rotation-y thing. Right. Okay, so part B. Outer dome of a large cathedral has the shape of a hemisphere. Okay, supported by these walls. Great. And there's an inner dome. Okay. Find the volume of the space between the two domes. Ooh. Is there a formula for this? That's a good point before I start. Yes, there we go. Volume of revolution about the y-axis. Sa is that. Okay, so from the formula booklet, I can say the volume of revolution about the y-axis. So if I rotate around the y-axis, this is what I want to do. So I can say it's called that V1. It's given by this formula. I did know this, but you know, I'm writing out the formula. I'm getting lazy. It's been a long old exam. A to B of pi x squared dy. Right, that's going to be helpful, but I need to know the space between the two domes. So outer volume, that's easier, is the cylinder piece at the bottom plus hemisphere. So cylinder, height 17, so that's 17 times pi. Radius is 16 times 16 squared, so that's the cylinder. And the hemisphere is going to be, sphere is 4/3 pi, so it's half that, 2/3 pi times the radius cubed, which is still 16. Okay. Right, calculate time. 13672. 3 is going to the nearest whole number, plus 2/3 pi 16 cubed, 8578. Okay, so plus 13672, 22250. Okay, 22250. Right, it's not the answer, but that is the outer volume. Now, volume of revolution. Okay, the inner volume, I believe, can be worked out from this formula, which is going to tell me that V1 was the integral from A to B of pi x squared dy. I think that was right. So, and because it's written as dy, that's telling me I need my limits on y. So, y is going from 0 to 33. So that right there is from 0 to 33, because it's a dy integral, so it's going from the lowest value of y to the highest. Yep. And I need pi, obviously, that can go outside. And then the x squared. Okay, so what do I know? I know that y is 33 minus 0.08 x cubed. So I need to work out what is x? So y, 33 minus y to the power of a third is equal to 0.08x. So x squared then is 33 minus y to the 2/3 divided by 3 minus y to the 2/3 divided by 0.08 squared. I think that's right. No. That should have a third there. So that's 2/3. Nearly missed that. Okay. Right, so I just do that integral now. So it's 33 minus y divided by 0.08 all to the power of 2/3 with respect to y. All right, so I assume you would normally just put this into your graphical calculator, which will give you the answer. But as I do not have one of those, I am going to try and do this by hand. Let's see how that goes. I don't think it's too bad, but so I think the inner volume then is going to be pi divided by 0.08 to the power of 2/3. So they're all constants. And then we have to do the integral from 0 to 33 of 33 minus y to the power of 2/3 dy. So I'm going to do the classic increase the power by 1. So that's 0.08, 2/3 doesn't change. So if we now increase the power by 1, that becomes 33 minus y to the 5/3, divide by the new power, so you get a 3/5, and that has to be evaluated at 33 and 0. 33 is, of course, not going to give me anything, which I love. So I think the answer is pi divided by 0.08 to the 2/3 times 3/5 times 33 to the power of 5/3. That lovely, lovely number, which I'm now going to have to type into a calculator. Definitely not enjoying the amount of calculation in terms of like using calculators, but anyway. 3, 4, 4, 7, I think. Okay. So now we have the inner volume and the outer volume. The question, of course, asked for the volume in between the two domes. So the space, as it's put in the question, the space between the two domes is equal to the outer, which I think was 22,250 minus 3,447. Again, calculator, obviously. So it's 22,250 minus 3,447 equals 18803 meters cubed. Right, and that, I believe, is the answer. So let's move on now to question 15. Where are you? Ooh, complex numbers, eh? Right, so Q15, complex numbers. Let W be this for A equals 2. Find the values of this. All right, so W is 2e to the pi by 4i, which is a 45-degree angle, isn't it? Yes, with radius 2. Interesting, okay. So what have I got to do? Find the values of them, right. So part 1 then, so W squared is just 4e to the pi by 2i, so that's 90-degree angle. W cubed is going to be 8e to the 3/4 pi I. Yes, and then finally W4 is going to be 2 to the power of 4 gives me 16, and then that's e to the pi I, so it's going a full 180 degrees, and I got to draw them. Perfect, that's what I wanted, because I'd already figured out what was happening. So, Argand diagram, which again, will not quite be to scale like theirs, but imaginary, real. Okay, so 2, so radius of root 2, and and it's e to the pi over 4i. So that's basically something like this. Let's call that one there w, or omega. Squared means here, which means going up to this distance now, 4. Right, so that will be 4, and that will be 2, right? Yes, not root 2. Talking nonsense, it's r, yeah, it's r e to the I theta. Yeah, so that's 2, that's 4. For 8, we're going over here. That has a distance 8, and obviously this is pi by 4. That's also pi by 4. And then we go all the way around to this one, which goes all the way down here to negative 16. And that one will have a length of 16. So it's rotating around and getting longer as it does so. Okay, and that's why the diagram goes to minus 20, because I'm going to need that minus 16 to go all the way around. Great, so I should label these. That's w squared cubed and to the 4th. Awesome. Okay, now let z be a different number. Let z for part B. Z is going to be w over 2 minus I, sure. Find the value of a. Okay, so going back to the more general case, so that's a e to the pi by 4i over 2 minus I. Okay, value of a for which successive powers of z lie on a circle. So it's a circle when mod z equals 1. Circle for successive powers. So what we saw there, just to explain my thought process, what we saw in the earlier part was the modulus was 2. So as we took powers, it was rotating it, but the radius was increasing as well. So if we make z have radius 1, we'll continue to take powers and go around the circle, but we won't increase the radius. But if it was any other number, smaller than 1, it would get smaller and smaller, and bigger than 1, it would get bigger and bigger. But if it's 1, any power of 1 will not change that radius. So I need the modulus of the top to be the same as the modulus of the bottom. Yes, so I can say the modulus of 2 minus I is real part squared plus imaginary part squared. 4 plus 1 equals 5, if I do it squared. And then the modulus of a e to the pi by 4i is a squared. So therefore, a is the square root of 5. Boom. Love it. Love complex numbers. Okay, that's 15, 16. Okay. Right. The number of fish. Whole range of different things going on in this exam. Number of fish that have been caught in 1 hour, a particular lake, can be modelled by a poisson. I don't know, we'd be raking a lake. Modelled by a poisson distribution. Poisson for fish. Very appropriate. The owner of the lake, Emily, states the average fish caught an hour is 3. Tom, keen fisherman, maybe when I was a kid, not so much anymore, is not convinced, and thinks it's less than 3. So I have to set up the following test, state a suitable null and alternative hypothesis. All right, back to stats. If you're not doing calculator, you're doing stats on this exam. Question 16. So, Emily reckons that the mean, so H0 is saying she reckons the mean is 3, and the alternative, Tom reckons it's less than 3. That's going to be our hypothesis test. Okay, find the probability of a type 1 error. So I know there are 2 types of errors, and it asks me to do type 2. Okay, so I think I've got to try and remember which one's which, haven't I? So I think a type 1 error is where, what would we do? Where we reject H0 when it is in fact true. I think a type 1 error is when you reject H0, and that would mean a type 2, because I'm going to need it for later on, So let me just make sure I'm remembering these correctly. A type 2 error is when you don't reject H0, right? When it is in fact false. So do not reject H0 when it is in fact false. Okay. And I was guided by the question because it gives me more information and says the actual number is 2.5. So it's telling me for part C and the type 2 that it's actually false. So that's what makes me think that one's type 2. All right, so probability for type 1. So we've said here that Tom rejects H0 if fewer than 2. So if x is strictly less than 2. Yes, and it's a Poisson, so less than or equal to 1. So i.e. The probability of type 1 error equals the probability that x is less than or equal to 1 given the mean mu is equal to 3. So I need the probability of getting less than or equal to 1 for a Poisson belonging to distribution 3. So you need a Poisson calculator, which I assume graphical calculator can do. I don't know it off the top of my head. Let's try it. Okay, probability of being less than or equal to 1 is 0.199. Cool, I'm going with that. Okay, good, sounds reasonable. Now, part C, so we're saying the type 2 error, so it's saying the actual number. So now we're being told that mu is 2.5. So we want the probability of a type 2, which is going to be the probability of what? If we were to not reject it, so if x was greater than or equal to 2, given mu is 2.5, is what I think I want here. So again, calculator, greater than or equal to 2 is 0.713. Okay, so much more likely we have a type 2 error in this question. Assuming I've got them the right way around. I think I do though, because the way the question was structured there helped me to remember. Right, which is that it? That is it. Okay, 17. There can't be many more left. Like I'm doing this forever. Question 17. Okay. Mr. Burke teaches a mathematics class, does he now? My chemistry teacher, high school is called Mr. Burke. Now he's teaching maths. With 15 students. In the class there are 6 female and 9 male. Okay, so probability of female is, again, obviously probability question, 6 out of 15, and probability of male is 9 out of 15. Sure. Each day he randomly chooses one student. Great. And he teaches his class 20 times. Okay. Let's see what they're doing with this. So it is 20 in terms of the number of times we've sampled. Yes. Find the probability. Choose a female. Okay, so we're doing, it's a binomial because we have a probability of picking, so it's NP, so it's 20, and the probability of picking a female is 6 out of 15. Which is 2/5. Yes. Right. So I want the probability of getting 8. So the probability that x equals 8 in that binomial is for, it's like n choose r, 20 choose 8 times, you need to get that one 8 times 2/5 to the power 8 times 3/5 to the power 12, n minus r. Yeah. Okay, so that should, graphical calculator, give me that answer. 0.18. Great. Sounds about right. Okay, right. Where are we going next? Oh, long question. Part B. The head of the year, Mrs. Smith, decides such student at random from the year group to read the notices. There are 80 in total. Okay, so 80 total. Probability of picking a male 8 in the first 20 assemblies. So n is still 20. And the probability of picking a male 8 times. So we still want the probability, but now it's like y. So probability of getting 8 out of 20. So it's still 20 choose 8. But now what's the probability of picking a male out of those 80 students, right? Yes. So the probability is x out of 80, where x equals number of male students, and obviously 80 is the total, so that's going to be the probability. And we need to pick those 8 times, and then we need 1 minus x out of 80 12 times. So it's very similar, but the probability's changed, I think, is what's happening. Yeah. Okay, let's try it. Well, can I try it? He says let's try it. I can't just plug it in because I know the answer, right, is 0.15. Ugh. Okay, and this is 0.153357. So let's do, okay, how am I going to work this out? So I have to set up this whole thing and rearrange. So, meh. Can my calculator just solve this? I'm pretty sure that's the equation. And I really don't want to have to work that out. So, because it's a 12th degree polynomial in x. So I'm going to assume my calculator could solve this, because there's no way you'd be solving a 12th degree order polynomial. So I'm just going to suppose I could set this up and solve it on my calculator. Ooh! There are lots of answers, but one of them is 37, which to me sounds like a real whole number solution, because obviously there'll be lots of solutions. So I get calculator tells me that the solution there is x is 37. Going with that. Definitely don't have time to figure that one out in my head. Okay. And surely, please be. Oh, there's more. Okay. Longest exam ever. Question 18. It's gotta be this, so close to the end, surely. Okay, 6 marks. The rate of a chemical reaction at a fixed temperature is related to the concentration by this equation. So A is equal to KB to the X, C to the Y. Sure. Scientist measures the 3 variables 3 times during the reaction. Obtains the following values. Find it. Okay. Simultaneous equations for X, Y, and K, where we're given A, B, and C at different points. Yeah. Okay, so immediate trick I'm going to use here is to take logs. So I've seen similar types of question before, and basically by taking logs, you turn the products into sums. It's much easier. So we're going to take logs and say log of A is equal to log of K plus X times log of B plus Y times log of C. Then plug in these values. So log of 5.74 equals log of K plus X times log of B, log of 2.1 plus Y times log of 3.4. So I'm going to put these numbers in now, otherwise I'm going to get fed up with working them out, I think. So I've got 3 equations here, here, and here, this one, yeah. 3 equations, so I'm going to write it, 3 equations, 3 unknowns. I'm going to assume again, surely my calculator is doing this, because I don't really want to deal with all of this algebra right now. Of course I could subtract them, substitution, elimination, usual simultaneous equation methods, given that I've used the log form to help things. But at this point, I'm totally done with calculation. So I'm going to get the answer according to those equations, which is going to be x is 1392 over 913, y is 468 over 913, and log of k is minus 753 divided by 182,600. So that's basically 0, which would say that k is approximately 1. I guess I can plug the others in the calculator, can't I? For x, that's about 1.52, and y, 468 over 913. 468 divided by 913 is 0.51-ish. All right, that, and that, and I'm done. Had enough. Better be it. Literally better be it. Yes! Oh my God. The relief of that actually being the end of this silly bloody exam, never ending, in about 1,000-degree heat over here. Thank you UK heatwave. Right, so that's 18 questions to our exam, 110 marks. I'm not even sure I've got the headspace to talk about how I found the exam. I'm going to go and have very much a lie down, cool off, and then I'm going to come back, talk about how the exam was, how I found it compared to the other exams I've done, and most importantly, we'll do a very quick run through of the mark scheme. Whilst past Tom goes for a lie down, let's all take a well-deserved breather to check out the fantastic content available from CuriosityStream, the best place to find and watch documentaries about science, history, technology, nature, travel, and of course, maths. Within the subcategory of maths, there are 3 excellent series to choose from. Nature's Mathematics, which looks at the patterns and formulas that occur in the natural world, Mathematics from live performer Arthur Benjamin, and a crash course in statistics from the brilliant John and Hank Green. There are also related documentaries in the science category, such as Engineering the Future, which looks at the exciting developments happening right now in a wide range of fields, an hour-long documentary on volcanoes entitled The Fires of Creation, and my favourite topic, fluid mechanics, as part of season 4 of The Butterfly Effect. And the best part is, new content drops every week, so you'll never run out of things to watch. Subscribe to CuriosityStream now using the code on screen or via the direct link in the video description for 25% off and start exploring the world around you. Whew. Wow, that was something. I don't know whether it's the incredible heat of the studio and the current weather outside, or just the sheer volume of questions that I had to actually go through in that paper, but that really felt like stressful. I feel like, I just went and tried to have a lie down, ended up pacing around because I've just got so much, stressful, nervous energy going on. I think the concepts, try and think about this properly, the concepts were fine. It just seemed like there was a lot. And again, I don't know if this is just because of the heat and the sort of lights all shining on me and making it feel more intense than perhaps it was. But it felt very challenging for time, definitely compared to, let's say, the A-level exam. I think on the A-level exam, I was able to do it in almost half the time. But this one, it felt like the time was a pressure, sort of constantly there, being like, hurry up, hurry up, hurry up. I was consistently thinking to myself, I need to hurry up. In terms of the actual questions, there's a lot of statistics. I don't know if that's a key focus of this particular exam. I guess, given it's called Applications and Interpretations, it would make sense that it's testing how to use probability and stats to actually get meaningful results. And I liked those questions that asked you to interpret it correctly, because that's something that's often done wrong in the media in particular. So I thought that was interesting. Lots of computation, which again maybe is hinting at more realistic questions where everything isn't a whole number. Measurements are horrible, so you need to get used to using real numbers. You need to get used to solving complicated, horrible expressions is what it felt like. As you could tell at the end, I got a little bit fed up with that. I was very glad it was done because some of those logs and all kinds of binomial things at the end, to me, didn't feel like maths. It just felt like, can you enter this in a calculator? But getting to the equation, I did enjoy. It was just sort of, literally inputting it into the graphical calculator that I don't have. That was the bit that it felt like I was doing a lot of. Again, I don't know if that's just this exam or the IB in general. Don't know. Enjoyed there was quite a bit of biology in there and applications, the phase plane stuff. That was a nice question, even though I probably went over the top because I knew too much. But yeah, no, I'm interested to see how I did. I think there's a couple where I forgot the particular terms. I'm sure we'll see when we look at the mark scheme now. But I think overall, I feel like I knew what I was doing on the questions, but whether or not my answer is correct, it's probably going to be some algebraic slips, probably a minus sign, knowing me. I love forgetting a minus sign somewhere. But we'll see, I guess. So I'm going to go through the mark scheme. I'm going to do this really quickly because this is already a very long video. And I'll just focus on maybe the ones that don't agree. But if my answer agrees, I'm going to be like, yes, marks, let's move on. Okay, so let's mark it. Right, lots of instructions. I don't really care about that. Okay, so actual question. Question 1, what was it asking? Discrete, K is 31, and systematic. Straight away he's dropped a mark. Okay, so that was out of 6. So I'm going to get 5 out of 6 because discrete was correct, that was wrong. So that gives me 5 out of 6. Systematic sampling. I knew I'd forgotten the word. Organized sounds like the same thing to me. Anyway, I'm not bothered about that. I just didn't know the term. I knew the maths. Right, number 2. Where are we going next? It should be 20. Yes, lovely inverse graph. That looks good. Perimeter is 8, area is 4. Perfect. 5 out of 5. Okay. Question 3. 1750. Yes. 1480. Or accept 1481. I wrote 1481, so I will accept it. And then 1350 or 1351. Oh no. 9.32, sorry, first. And then I should have something about 1350, 1351. Excellent. 6 out of 6. Good. Number 4. What are we doing? 0.5. Yeah, a half. Oh, this equation, y plus 2x minus 12. Excellent. Every point in the cell is closer to E. Is that what I wrote? I think I wrote it somewhere. Whoops, not there. There we go. All points in the cell are closer to E. Great. 6 out of 6. So just the 1 mark drop so far. Number 5. Log, as in actual wooden log, lumberjacking. 0.873. Yep. And then 45800 or 4581. 1 point. Yes. Yeah. To significant figures. That's correct. I just didn't round. It's fine. Number 6. Okay. What we got? We've got 2 nines. Yes. We've got 33 over 18. Yes. And we've got 6 over 324. Yes. That's 6 out of 6. Fabulous. Number 7. 20 sine squared t. Fabulous. 40 sine t cos t. Yep. And t is 0.126. Woo! 5 out of 5. Question 8. 20 something degrees. Yes. 2.45 meters. I enjoyed that one about the security camera. 8 out of 8. Good work. Number 9. Oh, weird statistics one again. 0.0. Okay, so that was right. 1.463. 1.493. Oh, the answer is 1.464. Ooh. All right, so the answer here is slightly different to mine. It's shifted down by 0.002 and up by 0.002. I've done the right, I know I've done the right method. So I'll get 1 out of 2 for that then, fine. Because I've not got the right numbers. I must have made a slip maybe, algebraically, or possibly subbed in the wrong value of S for the sample mean. And 95% of the time, the results we produce by population with mean less than that. Yes. Okay, so that's 4 out of 5. So that's 2 marks dropped so far. Remember this. Question 10. 0.961. 6 marks. Beautiful. Let's not hang around. Question 11. D is -2. Yep. A is 0.4. Yes. Love it. Another 6 marks. Number 12. The models, right. 0.526. Yes, that looks right. 0.17-ish. Meh. Close enough. They've got 0.17. I've got 0.168. Same thing. Choose model B. Okay. Award final A1 if it's a correct deduction from their calculated values. I'm giving myself, I'm slightly out, tiniest out on the decimal point, but again, it's probably just rounding. I've done everything that's in the mark scheme. I'm having those because that's actually correct. Ooh, question 13. So -1, yes. Okay, and then what have we got to do now? Asymptote of trajectory along. Oh, so it's like they want the asymptote of the trajectory to go along the line 2, 1, which, wait. Asymptote of trajectory along 2, 1. So they've got it going out. Have I done this the wrong way around? I've done this the wrong way around. No wonder my diagram didn't make sense to me. It's supposed to go out. But it says trajectory begins with a negative gradient. Oh, I'm so confused. They don't have any pictures either. So I've got it going along the 1, 2 direction. Oh, and it says award M1, but it can begin with a negative gradient. It definitely does it begin with a negative gradient? No, it doesn't. Oh dear. I think I might have dropped more marks there, you know. I think I'll give myself 2 out of 4. I was, in my head, I was determined it was going to go towards the fixed point. And I think actually it should have been going away. My diagram was telling me that it was meant to go away, and I for some reason ignored it. That was very silly. Anyway, that's 1 or 2 out of 4. I'll give myself 2 because I did draw everything perfectly and then just draw a very silly trajectory that didn't fit, and I was like, why isn't this fitting? Turns out because I was drawing it wrong. Anyway, lesson learned. Okay, so that's 13. 14, not many to go now. A is 33, good. B is 2 point. Kind of cheated and wrote down both answers because I had enough by this point. Sure, I can have it. And then volume was 18. Ooh, that sounds right. I did get 18, didn't I? 18,803. There we go. Right, so that's 8 out of 8 for that one. Fantastic. And then 15. Okay, 40 to that one, 8 to 16, and they're all increasing, yes. And then drawing them, getting bigger, beautiful. And A at the end, root 5. Amazing, 7 out of 7. Question 15. Question 16. This was the hypothesis test. So M is 3 or M is less than 3. Yes. Oh, did I get the errors right? Type 1 error is X less than or equal to 1 is 0.1. Get in. I did. Question helped me. Forgot which one it was, looked at the question, and it kind of told me the answer. Very helpful. And a good technique, remember that. 6 out of 6. Okay. Oh, 2 more to go. This is almost as long as the exam itself. 0.18, yes. And number of male students, 37. Get in. 6 out of 6. And then the last question, this horrible, horrible solution-y thing. They've used logs as well. Good. Right, brilliant. Done that, done that, done that. Attempting to solve it and then getting the answers. I mean, I didn't really do these very accurately, but I've got 1.52, they have 1.53. It's the same thing. I've got approximately 1, they've got 0.99s. I mean, I've written the right equations, I just got very lazy. But I'm going to say, again, I don't think any maths was incorrect, maybe just some rounding, as it was on a couple of them. So I think what that means, putting it all together then, is, trying to think back now, so I got 4 marks on those ones, yes. So there was the lost marks on the phase plane, that's very, very silly of me. So that's -2. And then, what did I get? I dropped 1 mark on the confidence interval, because I think I possibly used the wrong sample mean, maybe, or forgot a root n somewhere, so that's 3 marks dropped. And then I think it was just the sampling technique at the beginning. Yeah. So I think I've dropped 4 marks. So if it's out of 110, I believe I've scored 106 out of 110, which obviously is a fantastic score, as I should be getting as someone who teaches undergraduate maths at Oxford University. But I think probably about right. I knew something was slightly amiss on the phase plane. Confidence interval, I was kind of guessing in terms of how that had been taught, because it was different to what I was used to. And the sampling, I literally just guessed. I forgot about that first question, but yeah, I basically just guessed and guessed the wrong word. So that's it. I have completed the IB Mathematics Applications and Interpretation higher level specimen paper with a very respectable score of 106 out of a maximum of 110. Content-wise, felt fine. Timing felt very rushed, especially because I didn't know what I was doing with all of the calculation, graphical calculator stuff. I'd say probably, definitely harder than A-level maths, possibly similar to A-level further maths. They feel like equivalent kind of exams in terms of the way they're getting you to think about things, I think was key. Content, you know, kind of the same, but it was the way the questions were structured. It was like a little bit more on that critical analysis, critical thinking side, and rather than just, you know, do this, it made you think a bit more about which particular method and technique you wanted to use. So somewhere between, you know, maybe like around A-level further maths difficulty level, but not as hard as the Cambridge step. I think that's going to remain the hardest one that I'm going to do, because I definitely do not want to try anything harder. As always, thank you to all of you for watching the video. Please do remember to subscribe to the channel if you've enjoyed this, and I'll see you all very soon with some more maths fun. Take care.